What's up, guys? You are welcome to the GMAT41's YouTube channel. I hope you are doing good. So in this video, I'll be solving this question which I left from our previous tutorial class. Remember that we had this question number 7 here. Alright, to solve, but I told you that we're going to see that in the next video. And of course, that's what this particular video lesson will focus on. Just as a reminder, in our previous tutorial, I taught you how you can obtain the differential equation that has a given primitive. We looked at question 1a to question 6. Because I gave you question number 4 and 5 to try and then drop your answers in the comment box. So today we are going to see how we would deal with that question 7. Are you following right? In that question 7 we have y to be equal to c1 cos 3x plus c2 sine 3x. I don't mind that pronunciation. Cos and sine, they are actually hyperbolic functions. So have this hyperbolic cos and then hyperbolic sine. That h there represents hyperbolic. The pronunciation is not an interest anyway, but although that's the correct way it's been pronounced, sine, cos, have that of tanh, shek, and the rest of them. Anyway, let's move on to the business of this video lesson. So that's solution to question number 7. And so we're asked to find the differential equation that has this primitive. Like I explained in that previous tutorial class on O.D.E, I told you that your interest, once you are given something like this, is to check for the number that represents the what? Root of the auxiliary equation extracted from the differential equation that has this primitive. Are you following right? And of course, I gave you the secret. For example, when we treated this question, I told you that the root of the equation is obtained from the coefficient of x. So in the same way, like in this case, the root will be obtained from this coefficient of x. Are you following right? Which here is 3. But I would not want to just jump into this quickly. I would like to once again show you solution number 5. Remember in that previous tutorial class, I showed you 5 solutions. The 5th one was based on this hyperbolic guy. Are you getting me right? So I'd like you to see it once again, please, as it displays on the screen. So we have y equal to a cos beta x plus b sine beta x. So once you are exposed to a primitive that contains this hyperbolic function, sine and cos, the root of the auxiliary equation of the differential equation that has this solution, that root is obtained from that beta. Are you following right? That beta is what makes up the root. And I also want to state clearly that the auxiliary equation of this form of solution only has the real part in its root. Only has what I said, the real part in its root. There is nothing like imaginary part in the root of that auxiliary equation. So you don't expect anything like I, just like you saw in our previous class in the case of trigonometric function primitives. Are you following right? So here, I would like you to take note of the fact that the root of the auxiliary equation in this case will simply be equal to, this is how it appears, plus minus beta. Plus minus what? Beta. There is nothing like imaginary there. We only have real numbers in this case. Are you following right? Now, our beta is simply equal to 3. Our beta is 3. So that the root of that auxiliary equation will now be plus minus 3. I hope you're following this analysis, right? And then once you know the roots, like I said, your problem is solved. We can split this thing into the 2 parts of each solution because you see you have plus and minus. So this is going to be m equal to positive 3, and then we have m equal to negative what? 3. Moving the numbers to m, we have m minus 3 from the first guy, and then bracket m plus 3 from the second guy equates to 0, expand. And then you get the differential equation that has this primitive. Let's do that together. M times m is going to give us squared m. Then of course if you do m times 3, looking for m raised to the power 1 term, m times 3 will give us 3m. Then minus 3 times m will give us minus 3m. Plus 3m minus 3m is 0. So the m raised to the power 1 term goes off. Finally we have minus 3 times plus 3, which will give us minus 9. And that is equal to 0. I think we have arrived. the differential equation that has this primitive will now become d2y d squared x plus, okay, that's minus this constant 9 will be multiplied by y, and then you equate to what? 0. You can still write the solution as y prime prime minus 9y equal to 0. And that's the answer. Now let me show you one funny thing about this guy. And the same thing applies to this particular solution. The same thing applies to it. Are you following, right? See, once you see this cosh guy as primitive of a given unknown differential equation, which you have to find, as long as the primitive is that of hyperbolic function cosh, all you simply need to do to get the differential equation is come to this guy, square it. You know, this 3, if you square it, you get 9, right? And then your answer will simply be d2y d squared x minus the square of whatever you have here. Am I communicating? Then you equate to 0. In this case of number 3, that has sine and cos, remember there is nothing like exponential alpha x here. Are you following, right? It's just a sine x plus b cos x. For you to directly get the differential equation that has this solution, all you do, come to the coefficient of this x, which in this case is 1, you know, square it. Square whatever number multiplying x here. Square it. If you square it, then the differential equation that has that solution will be d2y d squared x plus, take note of that sign, plus the square of that coefficient of x here. Then you equate to what? 0. I hope you enjoyed the trick. Anyway, like I said, all of this have been explained from the main class where I taught you homogeneous second order ordinary differential equation. You know, when I generated that first solution, I explained what you should know about the root of the equation with respect to those solutions. So there are really, you know, technical knowledge we can really apply to get the differential equation that has this primitive as solution. Alright, I hope you enjoyed this video lesson. Please give GMAT41 thumbs up by hitting the like button. If you have not subscribed, what is holding you back? Please kindly subscribe, turn on the notification bell, personalize the subscription so that once I upload any new content, you will be personally notified. For further benefit, remember you can become a channel member. To become a member of our community, simply tap the join button below this video lesson. Select whichever package that is convenient for you, and then you would have the opportunity to become the GMAT41's channel member. Join our learning community for more benefits exclusively for members. I'll be seeing you in my next video lesson. Until then, make sure you take your studies seriously. If you have any question, make use of the comment box.